Alright, this is a short video that I'm making about simplifying exponential expressions. I got a short request about this, which is why this video will appear in the miscellaneous section of my channel. So we're just talking about simplifying exponential expressions. These are the rules that I'm going to be using. And let's have a look at some of the questions. I'm looking at negative 4x cubed times y raised to negative 4, all of this squared. Now, since it's a product of expressions, I'm firstly going to use this rule where if I have a product and the entire product is raised to another exponent, that exponent gets distributed evenly among the factors. So this is going to be negative 4x cubed. I'm first going to distribute the 2 like that, times y raised to negative 4 squared. And again, in this I have another product, so the 2 is going to get distributed again. This is going to be negative 4 squared times x cubed squared. And for this, I'm going to apply this rule here. Same thing. Where this is going to be negative 4 times 2. This is going to be 16. This is going to be x raised to 3 times 2. This is going to be y raised to negative 8. So the final answer 3 times 2, because of this rule, if I already have an exponent and I raise it to another exponent, that simply results in a multiplication of the exponents. This is going to give me 16 x raised to 6, y raised to negative 8, and people don't like writing it with a negative power, so this is going to be 16 x raised to 6 divided by y raised to 8. Let's look at another one. Here we have negative 2y raised to 4, all that squared. Again, we see that this is a product of two factors, so I'm firstly going to have to apply this rule, where the power on the outside gets distributed inside among the product. So this will become negative 2 squared times y raised to 4 squared, which will now become 4. Negative 2 squared is 4. And this will be y raised to 4 times 2, according to this rule, is 4y raised to 8. Alright. Let's do a few more quickly. 2x cubed y raised to negative 3 over 2y x cubed. Now it's all multiplication in the numerator, all multiplication in the denominator. So I like to rearrange a little bit and just visualize things slightly better. So I'm going to leave this as 2x cubed y raised to negative 3, but in the denominator I'm going to make it 2x cubed y. Since it's y times x cubed, it's a product, it doesn't matter what order I write it in. So I'm just rearranging it to help me visualize better. And since it's all a multiplication, I can start simplifying firstly, and I can start by getting rid of the 2. Then I realize I have a multiplication up here, I have a multiplication. The base is the same. I can subtract the exponents, so I can make it x raised to 3 minus 3 according to this rule, right? Where if the base is the same, I simply subtract the power of the denominator from the power of the numerator. And I do the same thing here. With y, I have y raised to negative 3, and this is like having a y raised to 1. So since I'm bringing it from the denominator back up, I'm making it negative 1. So I'll have x raised to 0 times y raised to negative 4. Now anything raised to 0 we know is 1. So this is 1 times y raised to negative 4, and since we don't like negative powers so much, this is just 1 over y raised to 4. We convert the negative power into a positive power by simply pushing it down into the denominator. Let's look at another one. We have 3 y raised to negative 3 over negative 4y x to the 4. Now this is straightforward. Firstly, if there's any stray negative in the denominator, I'd like to push it back up to the numerator. I'm allowed to do that if it's only a single stray negative in the denominator and nothing up here. So I'm going to firstly make this negative 3y raised to negative 3 over 4y x to the power 4. And since I don't see any x in the numerator, I'm not going to bother so much with this x raised to 4. I'm just going to keep it as it is. I'm going to treat this as being y raised to 1. And so there I have a common base, and if it's a division, I know it's a subtraction of the powers. So this is going to be negative 3 y raised to negative 3 minus 1, which I have from down here, divided by 4 times x raised to 4. So this is negative 3 y raised to negative 4, 4x raised to 4. Again, we don't like negative powers, so what we're going to do in the next step, and the final step, is push this y down in the denominator, thereby making its power positive. So I end up with this. Alright, I seem to have run out of space, so I'm going to quickly have to make some space around here, which I'll do in a second. Alright, continuing. Let's have a look at a few more problems. I'm just going to quickly do as many problems as I can. We're looking at negative 2 x raised to negative 1 divided by 4x squared y raised to negative 2. Now, we'll keep the negative there as it is for now. Although, again, it's a stray negative, it's only 1. I can give it to the numerator. So I can make this negative 2 x raised to negative 1. And at the same time, I realize that I have an x down here. So again, I have a division, so I can move this exponent up by making it a subtraction, because that's what I do when I'm dividing and I have the same base, right? And down here it's just a 4y raised to negative 2. Now, with this, I'm going to end up with a negative 2x raised to negative 3, right? Minus 1 minus 2 is minus 3 over 4y raised to negative 2. Now again, it's multiplication. I can start simplifying a bit. And I realize that I can simplify the 2 and the 4. So this is 1's r and this is 2's r, right? So for now, I have a 1. I don't necessarily need to write it. I can say negative x raised to negative 3 over y raised to negative 2. And again, I do not like the negative exponents, so I have to get rid of them by shifting, in the case of x, from numerator down to denominator, but in the case of y, from denominator back up to the numerator, because every time I shift either from numerator into denominator or from denominator into numerator, I will have to swap the sign on the exponent. So this just becomes negative. The y now becomes a y squared, because it's already a negative, so when I push it back up, I'm going to flip the sign on that, and this is going to be x raised to negative, just positive 3. Because it was a negative, I pushed it down, I get a positive. Alright, let's have a look at a few. Well, this is probably the last easy one before we move on to some more crazy complicated expressions. I have a few of those as well, by the way. Anyway, what are we looking at here? We've got 2a squared b, b raised to negative 1 as it were, divided by 4a cubed b squared. Right. Let's just take care of the exponents immediately. We know what's going on, right? We have 2 over 4, a raised to 2 minus 3. This 3 went back up, so it became a minus. B raised to negative 1 minus 2. This 2 went up, so it became a minus. So firstly, we can simplify the numbers here. This can be 1. This is 2 again, right? So I have 1, which I don't necessarily need to write. A raised to negative 1 times b raised to negative 3 over 2. The 2's from there, right? You need to remember that. Also think of this, the whole thing being over 4 either way. even though move stuff over, there's still a 4 there. And again, I despise negative powers, so the only way I can get rid of these negative powers is, again, to push the a and the b back down into the denominator. When I do that, I'm left with nothing in the numerator, and in that case I have to put a 1 there. So this is 1 2ab cubed, and there you have it. Okay, let us look at some really crazy fraction. There's another new rule actually that I can add here. If I have, we've actually been doing that, I didn't have it written down here, but what we had was if I had a negative power, if I had a raised to negative n, and if I wanted to change the power in the end, I made it 1 over a raised to n. Power, sorry, if I wanted to change the sign, I did that by pushing the n a raised to n into the denominator, and that's why I got rid of the negative. And similarly, if I have 1 over a raised to negative n, and now if I want to get rid of the negative on the exponent, I can simply push it back up in the numerator, make it a raised to n. So the point is, every time I want to flip the sign on the exponent, I have to switch from numerator to denominator or denominator to numerator. Doesn't matter. There's another rule where if I have a over b, this entire fraction is raised to negative n. And this is the same as flipping the fraction inside, making b over a, and then having a positive exponent. This is the rule that we're going to make use of in this problem right now. So, what have we got? We've got 2m cubed p cubed, big negative in front by the way, over n raised to negative 1 p raised to negative 3 times negative m raised to 0 n raised to 4 p raised to negative 4, and then all of this raised to negative 4. Since I have a bracket and an exponent on the outside, I'm going to first take care of this exponent on the outside. So I'm going to firstly make it negative. Do not touch anything inside. M cubed. Oh, sorry. Actually, hang on a second. I'm just quickly going to pause and get rid of this. Sorry, made a little mistake. Since it's a negative 4 and it is the exponent on the outside, I'm going to take care of that first. But the way to take care of it is if I have a negative in this exponent, I can make this positive by just flipping what I have here, flipping the numerator and denominator. That is according to this rule here, right? So the negative stays, but what I'm going to get is the denominator, which now is my new numerator, right? P raised to negative 4 divided by this, which has now become my numerator, 2m cubed p cubed, all of this raised to 4. Now since it's such a big expression, let me try and take care of the things inside before I worry about the 4 on the outside. I've taken care of the negative, now let me turn my attention inside. So I have negative, let me gather all the n's, the p's, and the m's together. So I have minus, which was already there, n raised to negative 1 times this n raised to 4, right? So n raised to 4. Let's get all the p's now. Times p raised to negative 3 times p raised to negative 4 minus n raised to 0 divided by 2m cubed p cubed, all of this raised to 4. Now, here I'm multiplying the same base, so this is going to be negative. Negative is all. is already there, stays, right? N raised to minus 1 plus 4 by this rule, because I'm multiplying the same base, I can simply add the exponents. I'm going to end up with 3, which is going to be p raised to 1. It's going to be minus 3 plus 4 minus m raised to 0. Anything raised to 0 is simply 1. So times minus 1. That's it. And over 2 m cubed p cubed raised to 4. Now, I don't need to bother about the m. Its exponent is positive. I don't have any other m, so I'm going to keep it there. I'm just going to bring 3 up. So I have negative n cubed p raised to 1 minus 3, because it's coming from the denominator, so I need to subtract. 1 minus 3 means it's negative 2 times negative 1 over 2m cubed raised to 4. Now inside the bracket I can simply multiply the negative 1 with this negative. It's all multiplications, it doesn't matter what order I do it. If I multiply the negative 1 with another negative, that's going to be positive 1. So I can basically just treat it as having n cubed e raised to minus 2 over 2m cubed, all of this raised to 4, which just basically means each and every individual component raised to 4. So this is going to be n cubed raised to 4, which is n raised to 12, p raised to negative 2 raised to 4, which is negative 8, 2 raised to 4, which is 16, m raised to 3 raised to 4, which means m raised to 12. How did I get that? By applying this rule. I had an existing exponent and I was raising it to another exponent, right? Which is how I ended up with this. And finally, I'm going to continue in green because I'm running out of space. I'm going to continue here, just getting rid of the negative. Wait, did I pick the wrong green? Because I don't like negative powers, this is just going to be n raised to 12, 16 m raised to 12, 12, right? Times p raised to 8. That's the final answer where all the exponents are positive.